So welcome to this River Publishers book discussion. I'm Philippa Jefferies and I have with me Jim Bezdek, visiting research fellow at the University of Melbourne and pioneer in fuzzy logic systems and clustering. Today we are talking about his new book, Elementary Cluster Analysis, 4 Basic Methods That Usually Work. Jim, welcome and thank you so much for joining me today. So shall I start with the first question then? So
Yes.
I was just wondering what you think is the importance of cluster analysis. Why do we need it?
All right, before we do that, let me just, I'm sharing a picture of the book. On the cover, you can see these. Here are 5 clusters and 3 million points, and here's an IVAD image of them. This is an example that's in the book. And I want to point out 2 important things about the title of the book. The first one is 4 basic methods. So there are only 4 clustering methods discussed in this book out of the hundreds and hundreds and hundreds that are available. And the reason I chose to write the book this way is because these 4 methods are probably the basis of about 95% of all other clustering methods.
Oh, okay.
So if you understand these 4, Philippa, then you'll understand a lot about what's going on in this field. And the other important point about the title is the word usually. I chose it quite expressly to point out to readers that all these methods can fail, as every method in pattern recognition can fail. So I will illustrate that a little later. Next question, or first question?
So yeah, what is the importance of cluster analysis? Why do we need it?
Yeah, so, you know, we live in a world of data nowadays, 2021. Everyone is concerned with data. Everyone collects data. You may not know it, but your iPhone transmits data. Your iPhone collects data. People are stealing it. They're analyzing it. They're clustering it. Yeah. So there's hardly any data collection process that wouldn't benefit by grouping subsets into the important items in the data set. And we're going to see, I will illustrate that with some examples in just a minute. And the point is, clustering is everywhere. If you look at how influence messaging is controlled by Amazon, by Google, by Facebook, Twitter, you will know that people are being clustered into groups of voters or groups of buyers that are susceptible to a particular type of advertising. This is a perfect example of the use of clustering that we're all familiar with. So it's important.
Yeah, definitely. And you mentioned a little, but what are some of the really practical applications of the types of analysis that you discuss in the book?
Sure. So there are hundreds and hundreds of them. I have perhaps 24 covered in my book, but let me just mention a couple. So Siemens, which is a worldwide organization with 400,000 employees across the world, based in Germany, they use clustering for many, many things. They use it for preventative maintenance, predictive control of rotating machinery, hydraulic pumps, all kinds of things. They have it in their medical systems, and so forth. I have some friends at Siemens in Munich that use clustering in many, many ways. So that's one example. There's another German company named Management of Information Technologies in Aachen that uses clustering to service about 100 regional banks in Germany. Each bank has a net assets of manages about $10 billion, 10 billion euros, and clustering is used to group customers into people who are creditworthy, people who are not, people who demand this and that and the other thing. So this is a second interesting application. There are many medical systems that use clustering. I'm very familiar with one by Bezdek and Dickinson Company, which is another worldwide company called Paintegate. I happen to own the patent to it that uses clustering to do, blood analysis. And then the fourth one I could mention is Plexon Corporation in Dallas. They use clustering for spike sorting of neuron spikes that are collected by EMGs and EKGs and so forth. So, we could go on and on and on to stop. I mean, you just can't stop. So there are lots of good practical applications.
Yeah, definitely. And Your book sets out to help people realize the pitfalls of using cluster analysis, why they usually work, but not always. What are kind of some of the issues there are when trying to use cluster analysis?
Yeah, so I'm going to show three charts that show it graphically, but just let me start by saying all of these algorithms, the ones in my book, as well as many other algorithms, are now available off the shelf. A user who has data and wants to cluster could just grab one of these algorithms and run it. And unfortunately, or maybe fortunately, I don't know, every clustering algorithm will produce clusters on demand. That's their job, and they're going to do it whether the data has clusters or not.
Okay.
And so the problems you have is, if the data are in more than 3 dimensions, how do you even know you have anything useful or right? So there are many, many things that can go wrong. Now I'm going to go to these slides, if I can figure out how to do that. So here you see a little data set. I think it's 1,100 points in 2 dimensions. If you look at it, you, a human, may decide there are 11 clusters in this data set. Maybe not. Who knows? The point is you can see it with your eyes.
Yeah, definitely.
And so this is what I call human point of view clustering. Why human? Because we're doing it. We can see it. So here are the 3 big problems of clustering. First, in pre-clustering, before you cluster a set of data, you can ask yourself, how many clusters should I look for? Are there clusters? There are methods for doing that covered in the book. Here's a cluster heat map produced by the IVAT algorithm of this data set. You'll notice that you can't see them too well, but notice that there are 11 dark blocks along the diagonal. There's 10 here. They correspond to the 10 clusters in the ring. And this single dark block outside corresponds to the central cluster. So this is a way to look at data the way a computer will look at the data. And here in 2 dimensions, of course, we can see whether it's right. Once we have decided what to look for, we'll look for partitions. So second is clustering. I don't know if you use here as an example the k-means algorithm. K equals 11. That's the number of clusters. K-means is the most ubiquitous clustering algorithm on the planet. It's heavily covered in my book. You'll see here, there are, let me see if I can move this a little bit so I can see it. So you see yellow points are a cluster, the blue points are a cluster, and these points in the center, the dark yellow. So these red dots are the cluster centers. This is a computer point of view, cluster number 1. If I simply change K, the number of clusters you see, to 5, say, here's what K-means produces. A different computer point of view. Look now at the center cluster. Now the colors show the labels.
Oh, okay.
The center cluster has no cluster center, so most of the points in the center cluster are grouped with this setup here, dark green or whatever color it is. There are a few dark blue points grouped with this, and very few blue points grouped with this. The point is, K-means is happy to give you 5 clusters, and they're totally wrong.
Yeah.
Totally. So what do you do about that? Well, if you're in 2 dimensions, you'll look at this picture and say, well, I can see that this is right and this is not right. But the data in 4 dimensions, and by the way, most data is in 4 dimensions or more, you're stuck. You have to resort to what we call cluster validity indices. Here are a couple. The Davis-Bolden index tells you to choose U11, that's this partition here. The RAND index tells you the same thing. So after you get the clusters, you can try to answer the question, are they any good, using either cluster validity indices or images of this kind. Example, to show you just how easy it is to trick a computer, I think this will amaze you. If any human looks at this, they will see 3 clusters, 3 tiny little clusters, 10 points, 3 here, 10 here, 10 here, and 10 here. And this is a human point of view, because I can see it. Let's have a look at what K-means does. Just put these up. So if I ask K-means to look for three clusters, it finds them correctly, no matter where I start the algorithm. But if I ask K-means to look for two clusters, look what happens. It might find these, it might find these. If I ask it to look for four clusters, it might find these, it might find these. Well, here are 5 different computer point of view partitions of this simple little 30-point data set. You can tell, because you can see it, which one is right.
Yeah.
But if these data were 4-dimensional or 200-dimensional, you would have the 5 partitions and no way to know except to resort to cluster heat maps or cluster validity indices. These are the big, big problems that we have when we do clustering. And I think that's the end of my charts. Go back to this.
Okay. You mentioned that you
Now
can
what?
try validating your cluster analysis. How easy is that to get to work out how successful you've been, or to try and find which is the right result?
Well, Philippa, the viewers and the readers may be disappointed to hear this, but it's not so easy. These indices often fail. I've written 20 or 30 papers about them. Every one of them works for some data sets and not others, and that's just the way it is. And one of the main points of the book is the word usually. None of these methods really work great. And if you're going to use clustering, you need to be aware of that.
Yes.
And I harp on that over and over and over throughout the book.
Yes, okay. It's definitely important to know, I guess, how these can go wrong and what you should be aware of it when reading the results. Just to finish, any final thoughts on what you would like readers to take away from your book?
Yes, I have one more chart I want to share with you. This one. Only because I want to show you my fish. I always use these kinds of pictures. I like to have fun when I do stuff. It's important to do something important, but it's also important to have fun. And I tried to write the book so it's not only right and useful, but fun to read. The most important topics are these 4 things. We have the theory and applications of these 4 clustering models, which I call throughout the Fantastic Four. Secondly, there is a complete theory of Lloyd's classic K-means algorithm. This is not available in many places. Many people in machine learning use K-means and they don't know exactly what the underlying structure of it is. Probably the most important thing in the book. And its generalization to the soft case, the correct generalizations, all in there, theorems proved and everything. Thirdly, Chapter 11 is the long chapter about approximating clusters in big data sets using extensions of each of these 4 models. They all work sometimes, but not always. And this big data thing in static data is really, really important. And lastly, the book throughout continues to emphasize visualizing cluster structure in small data, big data, and streaming data. One more thing I'd like to add. Let me stop sharing here. Last thing I'd like to add is clustering is a lot of fun. If you're a pure mathematician, you can prove theorems. And if you're a data analyst, you can discover things in your information, your data, and everything in between. There's something in it for everybody. So you should learn to do it, learn to use it, and learn to love it.
Yeah.
Well,
well, thank you so much for joining me today, Jim. It's been really interesting.